You know, we spend our entire digital lives tapping, swiping, and clicking away. But have you ever just stopped for a second and wondered what's really going on under the hood? Well, there's this powerful, totally invisible engine that's making everything you do possible. So today, we're going to pull back the curtain on the single most important piece of software on any device you own, the operating system. So think about it. You tap an icon on your phone and bam! In what feels like an instant, your app just appears. It feels like magic, right? But in that tiny split second, this incredibly complex and beautifully choreographed dance kicks off behind the scenes. So what or who is directing this whole performance? Well, that invisible director is your operating system. Think of it like this. Your tap is the cue, and suddenly this invisible conductor steps up to the podium, ready to command an entire orchestra of hardware and software to play your song, perfectly in tune. All right, so let's dig into that idea, because inside every computer, there's just a world of potential chaos. You've got competing demands for resources, really complex hardware, tricky software, and the operating system's #1 job is to bring order to all that madness. It's there to conduct the symphony and make absolutely sure every little component plays its part.
So what is it really? The formal definition calls it the core software that manages, well, pretty much everything, from your processor and memory to your screen and keyboard. It's basically the fundamental layer, the middleman, that sits between the physical hardware and the apps you actually use. It's a translator and a manager all rolled into one, making sure everything can work together.
And you know, the very first performance our conductor gives is the second you turn your device on. You hit that power button, and a tiny little program called the Bootstrap Loader wakes up. It has one job and one job only. Find the absolute heart of the operating system, what we call the kernel, and load it into the computer's main memory. Once that kernel is awake, it starts firing up all the essential background services, sometimes called daemons, getting the whole stage ready for you to use. Okay, so the system is on, the stage is set. Now for the real magic. How in the world does the OS let us do so many different things all at once? This brings us to its next big role as a master manager. I mean, this just feels completely normal to us now, doesn't it? You're streaming some music, you've got a document open, notifications are popping up. But for a computer's processor, which can really only do one single thing at a time, this is an absolutely incredible juggling act. The secret to it all is how the OS handles running programs. And this is where we get to a key concept, the process. A process is really just a program that's currently up and running. So your music player is one process, your word processor is another. Now, some processes are independent, like a simple calculator. But a lot of them are cooperating. They need to share information. And the OS, it's the referee that steps in to manage all those interactions and make sure nobody steps on anyone else's toes. So to keep things from turning into a total mess, the OS does something brilliant. It gives every single process its own private, protected little slice of memory. Think of it like a little house. It has a room for its instructions, a room for its data, and some other flexible spaces that can grow and shrink while the program is running. The OS is the city planner here, making sure all these little houses never overlap or interfere with each other. Now, to see this in action, we just have to look at something most of us use every single day, the Chrome web browser. It uses a really clever strategy that perfectly shows off the power of OS process management. And here's the exact problem they were trying to solve. I mean, you've been there, right? We've all been there. You're on some website and all of a sudden it freezes up, or worse, your whole browser just crashes, taking down all of your other open tabs with it. That's because modern websites are basically complex applications, and sometimes they're just plain buggy. And here is the genius solution. The OS lets Chrome put each tab, each extension, into its own separate, isolated process, its own little house. So now, if one buggy website crashes, the operating system just shuts down that one process. The house for that one tab gets demolished, but the rest of your browser city keeps on running smoothly. Now, yeah, the trade-off is this uses a bit more memory, but it's a price most of us are happy to pay for that kind of stability. It is a perfect example of the OS being a master manager. All right, so the OS is a master manager for all our running programs. But what about all our stuff, our documents, our photos, our videos, all the data that isn't currently active? Well, this brings us to its next huge role, the ultimate digital librarian. Okay, this is a really important idea to wrap your head around. A file doesn't actually exist on your hard drive, not in the way you picture it anyway. A file is what we call an abstraction. It's a convenient story, a useful illusion, that the operating system tells us to hide the messy, chaotic reality of physical storage. And to keep this story believable, the OS acts like the most organized librarian imaginable. For every single file, it keeps this super detailed catalog card, tracking things like its name, its size, when it was last changed, and, this is a big one, who has permission to even look at it. This is the organizational backbone of literally everything we save.
Because honestly, if you could just peel back the OS and look at the raw data on your hard drive or your solid-state drive, this is all you would see. A massive, unstructured, totally chaotic sea of ones and zeros. No folders, no file names, no order whatsoever. Just an ocean of raw data that's completely useless to a person.
But add an operating system into the mix, and boom, the OS imposes a structure on that chaos. We call it a file system. It creates the entire world of files and folders that we navigate so easily every single day. It turns that chaotic sea into a perfectly organized library, where every single piece of information has its proper place. So, we've seen the OS as a conductor and as a librarian. Now we get to its final and maybe most critical role, the guardian. The OS is responsible for protecting the entire system from itself, from buggy programs, and of course, from malicious attacks.
And the key to being a good guardian is this really clever design principle, separating policy from mechanism. So policy is the what? It's the rule. Like, hey, normal users can't delete critical system files. Mechanism is the how. It's the actual code that checks a user's permissions when they try to delete something. By keeping them separate, the OS can be incredibly flexible. You can change the rules without having to rebuild the fundamental tools that enforce them.
And trust me, the OS needs that flexibility because it is constantly defending against a huge range of threats. We're talking everything from classic viruses and spyware to more sneaky attacks like privilege escalation or buffer overflows. The OS is the first and most important line of defense. So let's just take a closer look at one of these.
We'll use a simple analogy here. A lot of programs use these temporary holding areas for data, and they're called buffers. The easiest way to think of a buffer is just as a container, like a box that has a specific fixed size. It can only hold so much.
Okay, so a buffer overflow attack is deviously simple. An attacker tricks a program into trying to put way more data into that container than it was ever designed to hold. So what happens? The data spills out, and it overwrites adjacent areas of memory. A clever attacker can actually design that spill to contain malicious code, which can then be used to hijack the program. This creates a huge vulnerability. Now, modern operating systems have all sorts of built-in mechanisms to make these kinds of attacks much, much harder to pull off.
So, when you put it all together, what is an operating system? It's the conductor, bringing order to hardware chaos. It's the master manager, letting you multitask like a pro. It's the librarian, building a structured world out of raw data. And it's the guardian, protecting your system 24/7. It is, without a doubt, the true unsung hero of your digital world.
But here's the thing. Its job is never done. The OS has evolved from powering computers the size of a room to running the literal supercomputers we all carry around in our pockets. But as computing gets embedded in everything around us, our watches, our cars, our homes, the challenges of managing resources, ensuring security, and giving us a seamless experience are just going to get bigger and bigger. The next act for this unsung hero is already beginning.